Hello, guys.
Hello, welcome. A few people come in.
My name is Chris. I'm a tutor at the STEM Center. Oh, wait, hold on. I'm getting some feedback. I'm a tutor at the STEM Center, and today I'll be hosting the Math 101 review for exam 2. Just making sure that you guys are here for that specifically. We will be doing a Kahoot today, so I'm going to share that shortly. I'm just going to wait about like 3 more minutes just in case any more students show up, and then we'll get started.
Hi guys, my name is Trevor Rybeck. I'm the coordinator at the STEM Success Center. I will be kind of assisting today and monitoring the chat. So if you have any questions and you don't feel like asking to the great majority of people, you can always just message me in the chat and I can try to answer it there. One thing to note that this is purely for your practice, so please use it that way. I suggest getting a writing utensil, some paper, and practicing the questions along so that you can kind of get that feel for what it's going to feel like facing these problems on like an exam or something. It is a pretty small group. I will say this is for your benefit. So if you have any questions, feel free to unmute yourself and just ask or type in the chat. We want to make sure your questions are answered. After all, that's why you're here. I will be posting a link in the chat to collect attendance every so often. So sorry to bug you with that. It's just so that we can continue doing fun things like these. So does anyone have any questions about how this is going to work before we get started here? If you do have any questions, feel free to ask. But I do want to thank you all for joining us today. We're excited that you're applying yourself and willing to participate in such a thing. So I hope it is fun, and if not fun, then I hope it is some good reviews for you guys. So these will be questions similar to the material that you'll see that you've seen in this chapter. So it should be pretty relevant. Let's see. Oh, I'm so sorry. Yeah, you don't need to put your first and last name for the Kahoot. Usually I do the silly names. I kind of forgot to put on that feature. Just put whatever you want. You can keep it. You can stay as anonymous as you would like to. That was a good question. This isn't for, so the Kahoot is more for yourself as to whether you're getting the answers correct or incorrect. We're not doing this in a term of like it's not like a competition like Lilo and Stitch. That's a great name. So this isn't like a competition to see who can get the highest amount of points. We're doing this as this is an opportunity for you to get to test yourself and see whether you get the right answer or not. There's a time limit for each of the questions. It's somewhere in the realm of like 1 to 4 minutes, depending on this question. And the way that this is going to work is we'll allow you time to work on the question yourself. And then after everyone's kind of answered the question, if everyone gets it right, we might move on to the next question, but otherwise we'll probably go over it, see if you guys have any questions on the specific one. But like I said, this is all just for your benefit. So make this as good as it can be for you specifically. So I'll say that. So I see there's about 19 participants in the Zoom with us, and I'm only seeing a couple on the Kahoot. What is the third number of the code? Oh, I see the thingy's in the way. Is that a 3, Chris? I can't.
Oh yeah, that's a 3. Sorry.
Okay, here I'll put it in the chat. Got that great Kahoot music. Oh, okay. 333 4683. For anyone who hasn't done Kahoot before, go to www.kahoot.it. You'll see that in the top kind of left. And enter the game pin that's 3334683, and you'll get added to the game. I'm going to do the first round of me putting in the attendance link, so I will do that. And like I said, I will be here for your guys' support. But I will let Chris here take it away.
Okay, I'm just gonna wait a little bit more because it seems like we have 13 students in here. And I think so far just 8 have joined. So I'm just gonna wait a little bit more just in case people need to get in their codes.
And this will be recorded. I encourage you to ask questions and such. But this will be recorded so that you guys can refer to it. We'll stick it on our YouTube. I'm sorry, can you repeat what the attendance is for? Oh, I don't know. I'm not sure if I explained. So good question. Someone's asking about what is the attendance used for? Basically, it's just so that we can show that students are actually coming to things like this so that we can continue to offer it in the future. That was a good question. A good logistical question. You're like, we had 16 students attend the exam review, so we can justify doing it in the future. That's how a lot of stuff in education usually works.
Technically 13. Okay, perfect. Everyone's in here. Alrighty, I think now that everyone's in here, we will start with the first question. So just like Trevor said earlier, we're going to be answering these Kahoot questions as practice for your exam. If you cannot answer the question correctly and you're uncomfortable like chatting everyone, you could just privately chat me if you have a question about it, and I'll try to answer it for you. And if you are willing to speak up, please feel free to unmute yourselves because we do like participation. But, all right, we're going to start off with the first question. Is
anyone listening in, given there are 16 ounces in a pound, so how much is greater, 80 ounces or 5 pounds? Pardon the spelling mistake there. That is supposed to be bigger and not bogger. Oh, well. So you notice as you make answers, you can see the answers coming in. So yeah, and like I said, I am also monitoring the chat. So if you have any questions, feel free to let me know.
And if you feel you don't have enough time to complete the question before the time runs out, just go ahead and take a guess. There's nothing wrong with guessing. Okay, perfect. Seems like I think we're gonna go over this one really quick, just so everyone has clarification on it. I'm gonna stop sharing my screen on my computer and share it through my iPad, so we can go ahead and go through the review. So, 1 second. Can everyone see my screen?
Yes.
Okay, perfect. Alrighty, so the question's asking, given that there are 16 ounces in a pound, how much is greater, 80 ounces or 5 pounds? Well, we know that's, well, given if we looked up the conversion factor, if you guys did look it up, 16 ounces is equivalent to 1 pound. So that means in 1 pound, there is 16 ounces. Therefore, if we have 5 pounds. We're gonna try to convert that to ounces so that way we can have the same units. So that way we can see which one is greater, 5 pounds or 80 ounces. Now to do that, we know that 16 ounces is in 1 pound, so we're gonna simply do 16 ounces times 5 since we have 5 pounds. Now 16 times 5, if you do it by hand, it's actually going to come out to 80. And that's how we know that they are actually indeed equal to each other. Does anyone have any questions on that? All right, if nobody has questions, we will move on to the next question. So let me stop sharing, share through my computer. Perfect. Okay, I'm gonna go on to the next question. So the question is asking, in a function of f of x, the x variable is dependent, independent, decreasing, or y value. Perfect. So it seems that majority of you guys got it right. I'm just gonna give a verbal explanation on this one. So for the function f of x, the x variable, so in terms of x variable, we are specifically talking about variables along the x-axis. And typically the x-axis is usually your independent variable. And that's how we can differentiate between the dependent and independent variable, is we know that the x-axis usually signifies our independent variable, whereas the y-axis typically signifies the dependent variable. So if you just keep that in mind during the test, that should help you avoid confusion in terms of which one depends on which. Did anyone have a question on that explanation? If not, we will continue. Perfect. Good job, guys.
I see a few people came in. Just letting you know, you can join the game mid-game by going to the bottom right. There's kahoot.it and entering the game pin 3334683, and that'll add you to the game. And, so the table will be on the next slide with the actual question.
Okay, perfect. So according to the table, find the net or absolute change between 2005 and 2015.
Let's see, 2005, it's 28 courses offered, and then 2015, it's 42 courses offered. If you're having a hard time seeing this. The net change and absolute change are the same thing. So if there's any like confusion with the verbiage there, it's finding the net or absolute change is saying so net change and absolute change are the same. So just wanted to mention that.
Perfect. So it seems that majority of you guys did get this one correct. I can go over an explanation just really quick because it's a pretty quick explanation for those who didn't understand. Hold Hold on, sorry, my Zoom's lagging. There it goes. Annotate. Okay, perfect. So the question was find the net or absolute change between 2005 and 2015. In 2015, we know that there was 42 courses offered, as opposed into 2005, which there was only 28 courses offered. So we would find to find the net change or absolute change, we would take the difference between 42 and 28, which is essentially is 14. Does everyone understand that? Okay, perfect. Perfect. So let me clear my drawings and then perfect. Good job, guys. So now the question's asking, what is the percent change from 2000 to 2005? It seems like some of you guys got this one right. I think we're gonna go over this one just because it seems important. Let me stop sharing my screen on this, and then let me share my screen on my iPad. Peace out, man. Have a good one. Okay, so the percent change from 2000 to 2005. Well, we know that in 2005, there was 28 courses offered, and in, oh wait, yeah, and in 2000, there was 20 courses offered. So we essentially will take our final value, subtract it from this is our final value right here, which is 2008, subtract it from our initial value, which is 20, and then divide it out by our other initial value, which is also 20. So then essentially what we would do is we would get 28 minus 20 right here, 28 minus 20, which of course you guys know is 8. And then we would divide that by 20 and multiply by 100. And if you did that in your calculator, are you guys allowed calculators for this test?
No.
No? Okay. Well, that makes it a little bit harder, but essentially if you wanted to do 8 divided by 20, do you guys know how to do that by hand? Or did you want me to give an explanation on that?
I think we know how to do it.
Okay. All right then. So, well, essentially you would get 40% after you multiplied by 100. Did everyone understand that? So just remember the formula right here that I wrote, V2 minus V1 divided by V1 times 100. That's essentially your percent change formula right there. So I would say if you don't have this written down already, definitely write it down right now.
Sounds good. I'm totally ready. All right.
Did everyone get that written down? Perfect. Perfect. So let me stop sharing. Share right here. Okay. So this one's asking, what is the average rate of change from 2010 to 2015? So this is different than the last question. Just letting you guys know. Awesome. I'm glad a lot of you guys got this one right. We're just gonna go over it just for those who got it wrong. So let me just stop sharing my screen right here. Then share screen right here. Perfect. Okay. So this one is similar to the problem we did earlier, except we're not using the percent change formula. We're using the average change formula. And the average change formula can be signified by y2 minus y1 divided by x2 minus x1. And remember what we said earlier about the x variable, is that the x variable depends, or the x variable is independent of the y variable. So that means that y depends on x. So years, aka like the time frame in 2000s, the year does not depend on the number of courses offered, but the number of courses offered does depend on what year it is. and remember what I said about how we can distinguish between X and Y. So once also another like hint is that typically time is always going to be your X value because time is typically independent. It's in most cases it's usually independent because time does its own thing. time don't Time doesn't depend on you, but you depend on time. Anyway, so knowing that we know that these values are our X's and these values are our Y's, we can plug the values into our formula. Y2 minus Y1 equals X2 minus X1. Now we know our Y1 technically our X1 is going to be 2010 and our X2 is going to be 2015. Now we would just look for the corresponding Y values, which are right here. X1, X2, Y1, Y2. So then we would do 42 minus 40 divided by 2015 minus 2010. That would get us 2/5. And then we would do the division and you would find out that it equals 0.4. Does anyone have any questions on that? Does anyone need more time writing this down? Since we won't have a calculator, how will we get this type of answer, or would they most likely not? We would get the answer by running it by hand, essentially. So, oh, okay, perfect. Thank you. Yeah, so we would just, I know it's kind of difficult because obviously calculators make our lives much easier. But for this exam, I guess you guys just need to practice your divisions and, just do a bunch of different division problems by hand, not just 2 divided by 5. Try problems like, 15 divided by 75. Like try big problems. So that way problems like 2/5 are easier for you in a sense. But yeah, that's what I recommend in terms of division, like division without a calculator, just practice. Okay, let's continue. Stop sharing right here. Let me share my screen right here. Okay. Okay, this one's gonna be a bit harder because it uses extrapolation, but you guys can do it for sure. I'll give you if this one's difficult for you, because I know this one is a bit more difficult, I'll give you the formula. Okay, so it seems like we're gonna need to go over this one. I know this one's a bit harder, but I think you guys can do it. Let's just go over it really quick. 1 second. Can you guys see my screen?
Yeah.
Okay, cool. So essentially, this is the extrapolation formula right here. Right here. And so this formula is gonna get you where you want to be. The hard part is just kind of figuring out where the variables go. So I kind of highlighted them right here. So this is gonna be our x1, our x2, our y1, and our y2. Now, a little thing for extrapolation that I like to do is extrapolation is basically getting you to predict a y value sometime in the future. So in this case, we're trying to predict an exam score based off the number of hours that were studied. So I like to like add an additional little box in my table. And this is technically what we're trying to do. It gives us this value right here, 11.5 hours. And then we're essentially plugging that new X value into our table, but we don't know our Y value. And that's what we want to solve for. So to solve for that, I'm going to use my handy dandy extrapolation formula. And this extrapolation formula, honestly, if you just like memorize all these formulas on flashcards, like you should be good. That's what I did when I was in math. And that's gonna help you like literally pass all your exams, is just remembering all the formulas. But the key about remembering these formulas is knowing where or what to plug in and where to plug it in. So like I said, since we're trying to predict a future outcome, we know that our future outcome that's being predicted is going to be the yx, or essentially what we're solving for. And given that, we know that in our formula, the x is going to be the 11.5 because that's what's given to us to solve for. That's the given x. Now, although we have x and yx, we also have these older values that were used in the table. And so these older values can help us extrapolate a new value. So we're going to take our y1, which is 75. And the reason why I use 75 and not like 65 just because it's the closest value to like to the end, or the close essentially, or even for 8 is closer to 11.5 and 10 is closer to 11.5. So I'm going to extrapolate just using the closest values. And that's how I'm going to signify what's x1, x2, y1, y2. So once I figured out my x's and my y's, I simply just plugged it in. So I know y1 is 75 right here. So I'm going to plug in 75. And I know my x is 11.5. So I'm going to plug in 11.5 right here. We also know our x1 is 8, and that's signified right here. And then, so on. So I'm going to just plug and chug everything. Once I plug in these values, it's going to give us this right here, 75 plus 17.5, because 85 are essentially this times this. It gives us 17.5, and then 75 is just given. So we're going to add these values, and we're going to get about 92.5. And if you notice in the actual problem, it asks us to round to the nearest whole. So 92.5 is about 93. And that's how we get this answer right here. I know I was talking like a lot and maybe fast. So if you didn't understand, just please ask a question. But if you felt like you understood, then I'll take your silence as a yes. Okay. Everyone has this written down, correct? All right, cool. I'm gonna go ahead and stop sharing from my iPad and then share on my screen. All right, continue. Alrighty. I'm just gonna give a quick explanation on this one, just because a few people got it wrong. 1 second. Um, so the graph looks something like this, and when we have like a graph that looks like a parabola like that kind of signifies it's concave up. And the way I like to remember it is like kind of like a cup. So for example, if I have my cup right here, and like it's kind of like this, right? Like it's kind of like, parabola. And we know the cup is opened upward. So that's how like we can signify concavity going up. Or if I flip the cup upside down, we know it'd be concave downward. So that's like a kind of like my explanation on in terms of concavity. But essentially that's how you can figure out if it's concave up or down. I also like, say if the graph is like this, I would add arrows at the end of the lines to tell me, which way it's going, which way the concavity is going. If I had a parabola pointing like this, I would put arrows and say, oh, it's concave down. For trying to figure out if it's decreasing or increasing, what I typically do is I kind of like draw little arrows like how I did right here. And these little arrows, like since these arrows are pointing down, that kind of signifies it's decreasing at first. And then as the arrows, as my arrows continue to be drawn, they start to be drawn upward. So that's how we know it's decreasing and then increasing essentially. But that's my explanation on that one. Okay, we're gonna continue. Good job, guys. Okay, in the function y equals mx plus b, the m is what? All right, guys, good job on that one. So essentially for y equals mx plus b functions, m always signifies like the growth rate or the slope. So if you chose the circle or the square answer, then that means you're right. Essentially the slope is the growth rate. So you can't really, they're both right answers, can't really get those ones wrong. The initial value, that's always going to be your b. The b essentially is where, like, so say I had a graph, x-axis, y-axis. The b is where your line crosses your y-axis. So essentially the b is your initial value, aka where x equals 0. So your initial value is where x equals 0, because that's the initial, your x is 0. And the initial value would be where it crosses the y-axis, so x is 0, and then wherever point it crosses the y-axis, that would be your b. So if it crosses the y-axis at 8, for example, your b is 8. In terms of x, that's just the variable, the x variable you plug in to get your y. But yeah, just remember m is growth rate or slope, b is initial value. And for like problems like equation problems like these, I tried to figure out, oh, is this problem exponential? Is it linear? Is it, I don't know, parabola? Like typically if you try to look at problems in terms of their graph, it makes it easier. Okay, so we're gonna go over this one just because it seems like a few of you guys got it wrong. So let me stop sharing. Okay. So thing. Okay, so okay, so for this one, essentially it's saying, so it gives us this equation right here, right? So that's the equation for life expectancy. And it's saying babies born T years after 2003, find the life expectancy for a baby born in 2008. So we know that in 2008, that was 5 years after 2003. 5 years after 2003. So I'm going to get this equation and plug in 5 as my T, because my T years, or AKA 5 years, has gone by. So I'm going to do 5, I'm going to plug in 5, and then 0.18 times 5. That's going to give me 0.9 essentially. And so we're going to do 0.9 plus 77.16. And that would give us 78.06. Does anyone need more of an explanation on that, or did you guys get it? So just remember that, read the full question, because sometimes it'll say born 2 years after. So then you have to account for the after part, which is like 2008 minus 2003. If it would have, or yeah, that's pretty much like kind of the thing that trips people up a lot. So just remember to read the full equation and just to take into account certain things like this. Okay, I'm going to stop sharing and we're going to go back to the Kahoot. Perfect. Next. Good job, guys. So this is similar to the last problem, but different in terms of what you're solving. So just pay attention to the problem, like I said earlier, and just read it carefully.
Thanks for filling out the attendance link. I'm going to throw it in the chat one more time just to get a few more people to do that. So do it whenever it's convenient.
Awesome. Good job, guys. Let me go over it really quick. So for this one's similar to the last one, where we're gonna use this equation that's given to us. The only difference is what's given. So in the last question, it gave us like t years, which was 5, the years that passed. But in this problem, it's just giving us the life expectancy. So what I'm gonna do is I'm gonna grab my equation right here, and I'm gonna plug in my life expectancy into E. So I'm gonna do 79.24, 79.24 equals 0.15 t plus 77.74. And I'm gonna solve for t. So to do that, of course, the first step we're gonna do is subtract. So since we're solving for t, we're gonna try to isolate it. So we're gonna try to put everything on the other side and get t by itself. So to get everything on the other side, first we have to do first we have to subtract 77.74 from this side. And what you do to one side, you have to do to the other as well. So 79.24 minus 77.74 is going to give us 1.5. So then I'm left with 1.5 equals 0.15 times t. Now I'm not done because the t is not isolated yet. The t still has this little friend right here. So to get rid of him, we're going to divide him out. Since it's being multiplied, we do the opposite and do that to both sides. So 0.15 divided by 0.15. And then we're going to do that to the other side, 1.5 divided by 0.15. And that's going to give us t essentially, which is 10. And I know it seems like we're done because we solve for t, but we also have to account for the fact that it's after 2005. We still have to account for that. So I'm going to do 10 plus 2005, and that's going to give us 2015. Did anyone have any questions on that problem? If there is no confusion, I will move on. If you guys are confused, please just private chat me or just unmute yourselves and ask a question. Let me stop sharing. Let me share on my computer screen again. Okay, let's continue. Okay. So this one's asking a savings account with $5,000 gains simple interest with annual growth rate of 20%. Find the value of the account in 2 years. So that word simple interest should give you a hint on what to do. Alrighty, looks like a majority of you guys got this one right. We're gonna go over it just so everyone has a good understanding. Okay, so from this problem, it's asking the savings account with $5,000 gains simple interest with an annual growth rate of 20%. Find the value of the account in 2 years. So the simple interest essentially should signify that we're going to be using the simple interest formula. And the simple interest formula is also known as PERT, PRT. So we essentially are going to multiply the principal value, which is our initial gains, by the rate, which is our percentage, and by the time, which is our years. So we got time right here, we got rate right here, and we got principal right here. Our principal investment is $5,000 times 0.2, aka 20%. We're going to convert that percentage into a decimal all the time. Okay? And to do that, of course, you just move the decimal 2 times to the left. Anyway, so it's going to be $5,000 times 20% times 2. And essentially, if you did it by hand, like if you want to know a fast way to do it by hand, I would do 5,000 times 2 first. That's going to give you 10,000. And 20% of 10,000 is $2,000. Kind of like in terms of like money. Like I just like to think of it as money. So like essentially 20% of $10 is $2. So yeah, that's pretty much how you do that. And then once you get that $2,000, you're not done because the $2,000 is essentially the simple interest, just the simple interest only. But that's not the value of the account. The value of the account is the simple interest plus your initial investment or plus your principal value. So I'm gonna do $2,000 plus my principal, and I'm gonna get 7,000. And that's how you get that. Does anyone have any questions on that? Okay, no questions. We're gonna move on then. Stop sharing. Okay, so the number of students involved in art decreases by 5% each year. If 1,000 are involved in art, how many will be left in 4 years? A hint for this one is that it's not the same as the last problem. It's different. So that's my hint. Alrighty. So let's go over this one. So I understand that this one might have been a little confusing, just because of the wording of everything. But essentially for this problem, we're going to be using this equation right here, which is y equals cb to the power of t. And I know this equation is typically used for exponential functions. And the reason why this problem seems a bit hard or is like harder is because it's kind of worded weird. Honestly, like the wording of the problem makes it seem like a linear equation when in actuality, I guess it is an exponential function formula. So the exponential function formula is y equals cb to the power of t, where c is kind of like your constant value, and then b is your base, and then t is your time. And for this, we're gonna basically plug and chug all our values. So the hardest part, I guess, about this problem is just figuring out like, oh, which formula do I use? And once you figure out that it is an exponential function, then you can say, oh, okay, it's y equals cb plus t. Well, I know that 1,000 are involved in the art, and so 1,000 is going to be your constant value. It's constantly going to be 1,000 at the beginning, aka your initial. And I know that our base is essentially also known as our rate, and it says 5% each year. So that would make you want to do 0.05. But this word decreases signifies that you're actually going to do 1 minus this percentage. So 1 minus 0.05. And that's going to give you 0.95. So this is going to be our B. So now that I figured out that the B is 0.95, I'm going to plug that in as our base for the equation. And it gives us the time that passes, which is 4 years. So that's how I know to make it to the power of 4. So once you create this equation, essentially, you can solve and insert it either in your calculator or do it by hand, because I know for the test you have to do it by hand, and you will get 815. How do we figure out it's an exponential function? Good question, Melissa. A good way to figure it out if it's exponential is, if it's exponential, typically say decreases or increases by a percentage. So if it says decreases by 5% or increases are 5% by 5%, that's how you know you're gonna do you're gonna use this exponential equation right here. Is there any other questions? And if you still have like the same question, you can ask it again so I could just word it differently if you didn't understand the first time. So yeah, just remember exponential functions will typically have like words like decreases by 5%, increases by 5%, whatever. Whereas like essentially linear problems like this, it's linear because it kind of follows the y equals mx plus b thing. So we know that our m is 0.18, our x is t, aka time, and our b is 77.16. So that's how you know you're able to use like it's linear because y equals mx plus b. Whereas this one, it says decreases by a percentage each year. So that's how we know that this is going to be y equals cb to the power of t, essentially. All right, let's move on. Okay, yeah, if you guys have to leave, no worries. I understand that this session probably will be in between your guys' classes, so no problem. I don't think this video will be posted on YouTube. I could ask my boss if we can post a recording, and we'll probably just send the recording out to everyone who joined. Hopefully, if we can record it or release the recording. But yeah, if you guys do have to leave, that's fine. I'm gonna probably go to the end. I might go past the hour 30. So feel free to stay or feel free to leave if you are busy, but I will continue until the end. Okay, let's continue then.
Before you go, I'll ask that you fill out the attendance link. Sorry, if you haven't left it.
So this one's a half-life question. You can tell by the word half-life in there. So 32 grams of carbon has a half-life of 250 years. How much carbon remains after 750 years? So just remember, like, the hint for this problem is that word half-life. That kind of signifies the approach you should take. Awesome, good job, guys. Looks like Looks like a majority of you got it right. For those who got it wrong, we will go over it right now. Let me just stop sharing. Share right here. So for this problem, it's a half-life problem. We know that because it literally has the word half-life in it. So when we see that word, we're going to use this formula right here. And that formula essentially it is our half-life formula. So this AO stands for our like original amount, essentially. AO, original amount. And original amount is 32 grams of carbon. So I'm going to plug 32 right here. And for the T over H, that just stands for our time, our total time divided by the half-life. So our total time is 750 years. That's how much time has passed since the carbon has been decaying. And we're essentially going to plug in 750 and divide that by 250, and that equals 3. So then once we get that, we can simply do 32 divided by 1/2. Does anyone know what that is? By head, in their heads? Well, essentially 32 divided times 1/2 is essentially 16. So then we do 16 to the power of 3. I'm just showing you guys this so like you guys can do it by hand when you do come across the test, because nothing's going to be done through calculator. So you do 32. 1/2 is the same thing as just divided by 2. So 32 divided by 2 equals 16. And then 16 is to the third power. So we would do 16 times 16 times 16. Oh, wait, actually, I made a mistake, guys. I made a mistake. Hold on. We would actually do, so do you guys, I'll tell you what my mistake was. And I hope you guys don't make the same mistake on the test. But whenever you're doing problems, we have to follow the order of operations. And for order of operations, if anyone knows what that means or remembers what that means, is essentially the PEMDAS rule. And so for PEMDAS, that just means parentheses, exponents, multiplications, divisions, additions, and then subtractions. And this is the order in which you're supposed to solve. So we know that there's an exponent right here, and exponents comes before, multiplying these two values. So we would have to solve for the exponent first. So we would actually do 1/2 times 1/2 times 1/2. And that would give us 1/6, or wait, my mistake, 1/8. 2 times 2 is 4, 4 times 2 is 8. So we get 1/8. So then we would do 32 times 1/8, which is essentially 32 divided by 8, which is 4. And that's how you would get 4 grams. So just remember the half-life formula. Like I said earlier, all these formulas I'm spitting at you guys, I would recommend like putting them in a flashcard and writing, half-life formula, flipping it over, memorizing it, pick up another card, oh, exponential formula, flipping it over, memorizing it. Just continue to do that. In my math class, we have also used initial amount times half of an exponent of h. How would we solve the problem with this formula? We have also used formula initial. Well, this is essentially the same thing, because this is our initial amount times half with an exponent of h. So yeah, so the exponent of h is your half-life. So basically, I think what you're saying, it's something like, let's just say AO times half to the power of h, right? Well, h equals T over h. So it's the exact same thing in terms of the formula you just said. Because the exponent of an h, that just means initial amount times the times half to the power of your half-life. Because h stands for half-life, and half-life, to solve for half-life, so h equals time over half-life. Or to solve for the h, essentially. But yeah, those are the same formulas. I just wrote mine, instead of like putting it to the power of h, I broke it down into t over h, just so it's more clear. Either formula works. I like this one better. Both the same thing, but this one's just more visually, I don't know, satisfying to me. Any questions on the half-life? We do not have any more questions. Just want to say, remember the PEMDAS. It's always important in any type of math you're doing. All right, I'll stop sharing on my iPad and we'll get back to the Kahoot. Good job, guys. So a rabbit population starts with 2 rabbits and doubles every month. How many rabbits will be there in 1 year? Well, essentially, this is kind of like our original exponential equation. So we're gonna do, does anyone remember the exponential equation? Can someone tell it to me, please? I forgot. Or put in the chat. Thank you. Yes, I was waiting for someone to say it. Yes, it is the CB to the power of T. Essentially, yeah, so we're gonna do y equals CB to the power of T. Oh, it's not letting me draw, hold on. Okay, CB to the power of T. And can anyone tell me what you think my C would be? What do I plug in for C to get the answer? Yes, 2, correct. Awesome, good job. So yes, we would essentially plug in 2. And does anyone want to know what our base is? Yes, 2, correct. Awesome. Thank you, Aline. Seems like 5 people solved for it, but no one's shouting out the answer. All right. So does anyone know what T will be? What is T? Yes, it's 12, exactly. Good job, guys. So we would essentially do 2 to the power of 12 times 2, and that would give us 8,192. Does anyone have any questions on that one? Okay, perfect. So just remember for these types of word problems, you're gonna, first rule is to figure out which equation you're using. Where it says doubles every month, that kind of signifies it being exponential, because if something doubles every month, it's gonna exponentially grow. So if I give you a penny and I say I'm gonna double your penny every day for the rest of the year, you'll probably be a millionaire by the end of the year, because that's an exponential growth. Okay, so let's continue. Let me clear the annotations really quick. Okay. I hope everyone can answer this question. But if you get it wrong, that's fine. Perfect. Okay, yeah. So some people said that B is the initial value. I understand your confusion. B is only the initial value if it's a linear function. So linear functions look like y equals mx plus b. And this is a linear function, so your graph would look something like this. Whereas an exponential function, so yes, or so for a linear function, b is your initial value, just to clear up the confusion. But for an exponential function, your b is going to be your base all the time. And the graph looks different than a linear function because exponential looks something like this, and then it slowly grows super fast. So it's kind of like this is linear, just a straight line, and then this is an exponential. So if I were to draw the axes, that's how it'd look. Okay, we'll continue.
So we can't do that.
Okay, guys. It's like a few of you guys got this one right, but we'll go over it anyway. So let me stop sharing. So for this problem, it's also an exponential function. There's only a slight difference, and it's the fact that we're gonna do 1 plus our inflation rate. So we're gonna use this equation again. And we're gonna, our initial value is $1,000. So that's gonna be our C. And our T is gonna be 3 years or 3. And the question is, what is gonna be our B? So I know it says 10%, so you may have been tempted to just do multiply by 0.10. But since it's inflating, that's kind of like an increase. So when there's like an inflation, we're gonna want to add 1. Whereas if there's remember where it said decrease and I actually did 1 subtracted by 0.05 and that's why I got 0.95. That was because our exponential was decreasing or decaying. Whereas if it's increasing or inflating, we're going to do +1 as opposed to 1 minus. So we're going to do, our B is going to be 1 plus 0.10. And so that allows me to create this equation right here. And so once you create that equation, you can just essentially solve. So 1 plus 1.0 is obviously 1.10. And since it's to the power of 3, we're going to multiply that 3 times. 1.10 times 1.10 times 1.10, which is going to give us 1.331. And then we're going to multiply that by 1,000. So when we multiply that by 1,000, that gives us 1,331. Does anyone have any questions on that? Alrighty then. If no one has any questions, and we'll just continue. Let me just stop sharing. Perfect, good job, guys. So, let me just. So for that one, sorry, I don't have like a picture of that graph, so I can't. It's gonna be hard to explain. But essentially, the graph, if you looked at it, if you looked at it around 20 Fahrenheit, like just visually, and you connected the x-axis, that would give you 6. So that's like the only visual explanation I can give. If you have any other questions on that, please put in the chat or ask right now though. All right, guys. So did you guys have any, if you guys didn't have any questions, we're just gonna move on. Let me just share my screen. Sorry, I was helping someone. So I wish I could go back to that graph just so I could show you guys, but anyway, on the graph, like if you just looked at it, I don't know why, like it's not letting me go back to it, but on the graph, if you just like with your finger followed that trend line up to 20 Fahrenheit, and then you went down to the x-axis, it would show you that 6 hours went by. Let's continue. Perfect, guys. Good job. All right, well, that's the end of our review session. If anyone wanted to go over any other problems or anything, I'm definitely willing to be here. Looks like majority of everyone left. But if you guys did have any other questions, please feel free to ask right now. My pleasure, guys. If you have no questions, feel free to leave and have a great day.